My dear friends, welcome to Rajashekar classes on applied data science with Python. This is lecture number 425. In this lecture, we will try to understand geometric intuition of Adaboost. There is an other popular boosting algorithm called Adaboost. It is also called as adaptive boosting. It is very similar to gradient boosting but with a couple of key differences. So, what I will do is instead of going into too deep in Adaboost, I will give you a geometric intuition of what is happening in Adaboost. Adaboost typically used in computer vision or image processing like applications. Of course, it is also used in non-image processing applications, but most successful applications of Adaboost are in image processing, especially in the case of face detection, wherein it tries to detect where is the face in an image. But for general purpose stuff, GBDT is very good algorithm, super good algorithm. So for this, what I have done, I have taken a toy example from University of Pennsylvania Computer Science Department. Somebody has done very nice example, and it would take me a lot of time to recreate this. I am borrowing this example and content from them just for this particular class. Thanks a lot to the people who created this phenomenal content, by the way. Now let's assume this is my data set. My plus here is positive data point, and minus is a negative data point. Let's assume this is my data set D1 at stage 0. This is at stage 0. From this, I train a model. Let's assume I trained a simple decision tree. Let's assume I train a decision tree with a depth equal to 1. What is depth equal to 1? It means depth equal to 1 basically means is a decision stump. And what is the decision stump? It is basically parallel to y-axis or x-axis. I just basically get a hyperplane. So here when I train it, what I get? My model H1, my first model is basically a line like this, isn't it? Is it not? H1 is a line which if you observe carefully, this is first round. If you everything left side of hyperplane is just see what is everything on left side of hyperplane, that's blue. Everything right side of the hyperplane is, let me say, red. These 3 points become error. Why? Because this plus must be in on blue side, they are on red side. Now for this model, I compute these 3 pluses are errors. For this model, I compute a weight alpha 1. What is alpha 1? 0.42. I compute the weight based on how many errors. Here how many errors we have? 3 pluses. And I compute the weight based on how many errors I got, how well this model performs on the original data and things like that. So I get a weight alpha 1 equal to 0.42. I have my h1 of x, which is nothing but hyperplane, isn't it? And alpha 1, I have alpha 1, even I have h1 of x. In first round, I can calculate alpha 1 into h1 of x. I have these 3 points. These 3 points are misclassified. Which points are misclassified? These 3 plus symbols are misclassified. Now what I will do here, before I am going to second stage or second round, I will increase the weight on these points. I will increase the weight of this misclassified points that are plus, isn't it? You may remember, you can do a weighted decision tree you can do weighted logistic regression, or you can say weighted model in general. In general, I can say it is a weighted model, isn't it? So what do weighted model means? One way to implement weighted model is upsample the points, because these points erroneous, this plus these points are erroneous. Just see, these points are erroneous at stage 1. What is a round, first round, isn't it? Because H1 misclassified this H1, what did this H1 misclassified these 3 points, isn't it? We want to give more weights to them. What is in Adaboost, what you have to do? You have to give more weights to them by upsampling them, or by creating a weight for each of these points. If you see, the size of plus is increased. Just see, the size of here, size of the plus, here size of plus. Size of the plus is increased. The larger plus basically means these 3 points are misclassified. We are making them big, or we are upsampling them while keeping the rest of the points which are correctly classified as it is. Now D2 becomes the, what is my D2? This is my D2. Yes, this D2. My D2 becomes the data set for my H2. When I go to H2, this is my H1, isn't it? Where is my H1? This is my H1, this is my H2, this is my D2. D2 becomes the data set for H2. When I go to H2, what happens? I have more, just see, in these are points. I have more weightage here, because this looks big plus, isn't it? In this point, I am doing what you are doing. I am doing upsampling. So if you see, the size of plus is also increased. Let's assume I am increasing the weight by some value. Typically speaking, you increase the weight exponentially. You increase the weight exponentially in adaptive boosting. There is an exact method in Adaboosting on how to increase the weight. But since these are increased weights, just see, these are the increased weights. Are they not increased weights? These are the increased weights. It will prefer to classify them correctly, isn't it? H2 will try to classify these points, these increased weights, correctly. So if my H2 will try to classify correctly, if my H2 is like this, my H2 is like this, it is corrected all of my oversampling points. Just see, it is corrected all of my what is the data set for this one? This D2 is data set for this one. Just remember, this one is data set for H2. That is important, isn't it? Now it is correctly it is corrected all of my oversampling points. These are the oversampling points. It is correctly classified. Which one is correctly classified? H2 is correctly classified, but it has created these errors. Which errors? Just see, these 3 errors. Even for this model, based on these errors, I can calculate alpha 2. Let me say alpha 2 equals 0.65, isn't it? So I have H1 alpha 1. H1 I have, let me write H1 alpha 1 from round 1, isn't it? Now you have H2 alpha 2 from second round, isn't it? Yes, I have H1 alpha 1 in first round, H2 alpha 2 H2 in second round, because these three errors, because I have these 3 errors. Now I will give more weightage to these points. Which points? These erroneous points. I have to give more weightage. Now I will train my third model. I have to train my third model. Just see this one. Yes, this is what is this? This is H1, this is H2, this is H3. Now this is what is this? This is my H1, this is my H2, and third model looks like this. This is H3. This is H3, isn't it? I am giving more weight to 3 negative points. These points, we are giving more weight. Just see, we are giving more weights to that 3 negative points. It will create hyperplane like this. H3, this is the hyperplane now. Hyperplane like this, parallel to x-axis. Is it not? This is parallel to x-axis, hyperplane parallel to x-axis, and it says what it says: the points above this particular hyperplane are positive points, the points below this H3 are negative points, isn't it? Now I have only one point which is error, just one. Which one is error? Yes, I have only one point. This is error. I have only one point, this error. Actually you are saying is here positive, but you have negative point. Here I have two errors. You are saying negative, but you have positive points. Now I have only one point which is error in the above hyperplane. In the above hyperplane, I have this error, isn't it? I have only one error point. Here in the below hyperplane, there are couple of points which are error. This is error. This is also error here. But these two positive points, these two positive points would have been taken care by H1. This one would have been taken care by H1, isn't it? And this particular negative point would have been taken care by H2, isn't it? By H2. So eventually what I will do here is my final model will look like this. My final model look like alpha 1 H1 plus alpha 2 H2 plus alpha 3 H3. This becomes my final model, my F3 of X, which is basically 0.42 times of H1, that is alpha 1 H1, plus this is alpha 1, I can say this is alpha 1 H1 plus this is alpha 2 H2 plus this is alpha 3, this hyperplane H3, isn't it? Your alpha i's here equivalent to gammas in GBDT. In GBDT, I can compare this alphas with gammas. So here what you are doing effectively, the key difference here in the case of GBDT, in the case of GBDT, we used pseudo residuals to compute pseudo residuals computed from the negative gradient of the loss function. Here in the first round, all the points which are misclassified or erroneous points are given more weightage using something called adaptive boosting. It is called adaptive boosting because at every stage you are adapting to the errors that were made in previous stage, and we are giving more importance to those points which are misclassified. This is the core idea of Adaboost, and as you have seen, you can get Adaboost in scalar gradient, gradient boost classifier, gradient boost regressor. So Adaboost I have not seen extensively in internet companies, but of course I have seen Adaboost and variations of Adaboost being used in things like face detection. Personally speaking, from my own personal biases, I have seen GBDT being applied much more than Adaboost, especially in internet companies. May be wrong with other companies, especially at internet companies. General purpose machine learning GBDTs are more often used than Adaboost. There are so many articles. This is an article related to same Adaboost, face detection using boosting. I request all of you to go through this lecture. If you have any difficulty, please keep a comment. Thank you very much.